So for quite a while now, I've been having the urge to build an autonomous HD FPV nanowing. Ever since I knew about the Nano Goblin and the Flik, the idea of designing an airframe fully capable of long range, long endurance, and autonomous flights while only weighing about 250 grams has always stuck with me. So I decided in this video I would give it a go at just that. A few months ago, I designed this little 3D printed airframe and it flew pretty well, but was a bit too fast for my liking. I figured it would make sense to just modify this airframe so it could be essentially my testing platform. The only real difference I made was make room for electronics like the GPS and modified the wings so they could be printed in a lighter yet stronger internal structure. If you want to know more about how I designed this grid pattern, you should check out my previous videos. One thing I decided not to include in this airframe was an FPV system, which turned out to be a huge mistake as you see later. For the flight controller, I'm using the SpeedyBee F405 Wing Mini running Autopilot. Autopilot is an advanced open-source autopilot software, great for any sort of autonomous vehicle, so I would highly suggest you go check it out if you're interested. For long-range capabilities, I'm using this Express LRS EP3 receiver. And for whatever reason, the 5V pin that powers the receiver was only giving 3.3 volts. So I had to split the wire connector to get power from a different pin. Yeah! I then soldered the motor wires to the Solo Good 20 amp ESC, and while running up the motor, I realized one of the screws was touching the coils, which caused it to blacken out. And now the motor is pretty much ruined. In order for this wing to have autonomous capabilities like return to home, it needs to have a GPS module. This essentially lets the flight controller know where it is in space. I mounted it towards the back of the hatch, but I had to move it towards the middle because the body was too short for all the wires. Poor designing on my part. While trying to configure the flight controller, I was having issues with bad terrain data, which made it so I couldn't arm the motor. Turns out it was just missing a SD card for the flight controller, so it was an easy fix. But what wasn't an easy fix was the way I designed the whole airframe. Not only was the carbon spar in the worst place possible, the whole body was way too short, which made it a struggle to fit everything in. But thankfully it worked out, just barely though. Unfortunately, I didn't get any flight video of the first test, but this is how the wing ended up. Not great. This is just what the airframe looks like when all the electronics are stripped out. It's a cool crash though. It looks pretty cool. I mentioned in my other video about this wing design that it was really fast. Not because it was heavy, but because it had very low drag and could cut through the air very easily. I also had the flight controller set up in a stabilized mode, which gave the whole plane a very large turn radius. Combined with the fact that I was just flying line of sight, the whole plane just disappeared into the sky within seconds. I did have return to launch as one of the flight modes, but I guess I just forgot that option existed while trying to bring the plane back. I decided for the next airframe, the priority would be changing the wing design. This straight skinny wing was great for efficiency, but when considering the fact it makes it a lot harder to land in smaller areas, is more unstable on pitch, and is less of a compact design, it's probably not the best choice for a nano wing. So I hopped on the Onshape and designed this. The wingspan went down from 25 inches to 20 inches, and the rootkord was lengthened quite a bit. For a different application, a very efficient skinny wing might work the best, but for my case, I'm just looking for a casual flying wing that has the ability to basically fly anywhere, so efficiency isn't that important. Another thing I did was make the body a lot more spacious and aerodynamic, compared to the previous design. But the part that stands out the most are the vertical tails. I got the inspiration from jackrabbit ears, and I just really like jackrabbits, so I thought it'd be cool to match the look on this wing design. A lot of the time, engineers follow nature in a practice called biomimicry. They do this because natural systems have been optimized for efficiency and functionality over billions of years. So it makes sense to use something that already works well and implement it into human technology. However, in my case, I'm just doing it because it looks cool. I'll explain later some trade-offs with this vertical tail design. I was actually really happy with how this new wing design looked, and reached out to a company that can cut EPP foam to see if they could prototype it. Compared to 3D printing, using stuff like EPP foam is just going to be so much more durable, convenient, and lightweight. So I was really hoping I'll be able to use a CNC prototype. However, they responded saying the cost would be around $1,800 for 120-inch wingspan airframe, which I don't know if there are any CNC experts out there, but let me know if that's right, because I feel like it shouldn't be that expensive. But yeah, I just ended up modifying the CAD so I could 3D print the parts instead. If I could do this over again, I would probably still try to make the airframe out of hand-carved and hot wire foam parts. It would be a lot more work and probably wouldn't look as good, but it would definitely be able to last a lot longer without needing repairs, and would have also been a lot lighter, making it possible to use bigger batteries. But oh well, I'll probably do that next video. The whole build and assembly went pretty straightforward, and I was just using the same electronics from the crashed airframe. One thing I had to consider was whether the main body should be printed in active lightweight filament or pre-foamed filament. So I did a test print of each kind, with different infill percentages to get as close as possible in weight, and I just ended up choosing the active foamed PLA because it was a few grams lighter. But I think I was too fixated fixated on weight and didn't consider the fact the body was going to need to take all the impact force while landing. After I had already built and tested the wing and faced the consequences, I took those past test prints and did a proper stress test like I should have done. And you can see the pre-foam PLA version is just so much stronger and more resilient compared to the active foam PLA. I probably would have chosen the pre-foam version if I did the stress test, but it's too late for that now. Here goes the tail section being glued on with the motor and ESC, and for the flight controller I wanted a way it could be mounted with screws instead of glue. So I printed these 3 pieces where the 2 smaller brackets are glued to the base of the body, and the flight controller can simply be screwed on. Making it possible to be removable became really useful in the future. After that, I printed the wings and elevons and realized there was no way I was going to get this thing under 250 grams, which I know was my initial goal, but I feel like with this airframe design, the electronics I was using, and the fact it was all 3D printed, that weight goal just wasn't going to happen. After getting most of the build done and getting the flight controller configured, the last step was installing the FPV system. I chose the Walksnail HD Nano V3 kit because it was really light at only 20 grams while still providing HD footage. The tricky thing with all digital FPV systems is that they get really hot really quick. So this made it a bit of a headache trying to figure out how to mount it. I was originally just going to go with some heat-resistant glue or tape, but I ended up trying this method of using zip ties with holes so they could be screwed on with M2 screws, and that seemed to work really well. Additionally, to prevent the VTX from overheating while the flight controller was getting a GPS fix, I split the 5-volt wire with a bullet pin connector, so I can power up the VTX once the plane is ready to fly. And that pretty much completes the build, so it was time to head out to the field and see how the thing would fly. I started with Autopilot's basic PID gains, and it was pretty clear I was going to need to make some changes, at least for the pitch. I tried to fly at different speeds to see if there were any patterns with the pitch oscillations, but they still persisted. This made me pretty worried that the landings were just going to destroy the swing, but it was pretty interesting to see that the oscillations would almost completely go away once it got closer to the ground. After a few landings, it was clear the lightweight PLA was not holding up, and there were a couple potholes in the body. I tried to fix it by patching it up with some tape, but I knew this was only going to hide the mess. After this few test flights, I tried reducing the P term for the pitch in Autopilot to about half what it was originally, but doing that only seemed to help a little. This made me believe the root cause was the bad CG, which would make sense as I've had the same issue in the past. I did some testing with the battery moved like half an inch forward, and that seemed to have taken majority of the oscillations away. It was at this point that the rest of the tuning could be taken care of by adjusting the parameters in the flight controller. I was originally just going to adjust the gains manually, but decided instead to use Autopilot's Autotune feature, which essentially tunes the aircraft based on the pilot's control inputs. I accidentally cut the auto-tuning time a bit too short, so only got through the roll PID gains. However, the aircraft did seem a lot more stable when flipped back in the fly-by-wire A. I was pretty happy with how the wing was flying at this point, so it was time to try out return to launch. It was working pretty well at first, but as the plane got closer and closer to home, the horrible pitch oscillations came back. At first I thought this was just because the elevons were still overtuned, but after watching the footage with the sound afterward, it looked like the oscillations were coming from the motor pulsing on and off.
It did work, it's just it has terrible pitch oscillations.
I didn't think too much of it and thought the flight controller just needed some more time in Autotune. But in the meantime, I did a casual flight to see how much better fly-by-wire A mode was, and it was definitely a lot better. Most of the oscillations went away, and the whole flight experience in general was a lot more stable. However, upon landing, all the oscillations came back and it led to a rough landing, which broke one of the tail fins off. Alright, it's time to see how botched up this this body is. Oh my god. You know what? It's not that, it's obviously pretty bad. But like, yeah, it's pretty bad. Oh boy. To hopefully fix this and give the bottom of the body some additional protection in the future, I cut out the sections that were damaged and tried my best to fill the voids with pieces of foam. Definitely wasn't that pretty, but at least for now, it should be able to handle some more landings without getting damaged. My goal with the next few flights was to finish the auto-tuning and get the PID gains dialed in, and to see if return to launch will work any better. However, I was a bit skeptical that just auto-tuning the flight controller wasn't going to stop the motor pulsing. I thought this because other than return to launch, the auto-tuning wasn't really necessary, because the wing was already flying fairly well in fly-by-wire A. After completing the auto-tuning process, it did seem like return to launch was working a little better, and didn't seem to have the pitch oscillations, but I stopped it a bit short because it was kind of flying out of the field. Ultimately, I think if I want return to launch to work really well, there are going to be some other parameters I'm going to need to change. For example, the bank angle is probably a bit too steep, which is what causes this scary dropping feel, and the motor throttle while in return to launch could probably be reduced, seeing how fast it goes. I haven't looked into these changes that much at the moment, and will probably focus on the autonomous side of things in part 2, but at the moment I just really wanted to do some casual fun flights, as that was the whole point of doing this project. That was not great. I got a whole tree stuck in my wing. So we got the plane back. Something I realized is that I don't know if it's the wind that has gotten worse, but it's definitely harder to land the plane here. Specifically like on approach, it's just bouncing around a lot. And then I get some like some rough landings, but I mean it is pretty rough ground here, but yeah, I don't really know. We're out of battery because these batteries are like go through really quick. But yeah, I got some good shots above the trees there. But I do want to get some extra, do some more tuning because it's still oscillating quite a bit, especially in return to launch. Return to launch is still a bit wary because like it looks like it's always going into the ground. But yeah, I think that'll be it. All right, so it looks like the Nano wing is in a bit worse condition than I originally thought. Of course, we got this here, but we also had this. Like this whole wingtip is completely destroyed. And there's just like, I don't know, there's just like a bunch of cracks all along the wings. And they're kind of just losing their structure at this point. And there's not a really easy way to fix this. I was thinking about I just like reprint the wing and like reassemble it, but that's a lot of work just because it's 3D printed. And I can't really just tape this because it's like the infill is also kind of like crumbled up too. So yep, that's the tricky thing with 3D printed wings, but it's kind of on me that I didn't decide to land at the empty park and I decided to land at the really rough terrain, so that's kind of on me. But I guess I'm going to need to do some more tuning next time, but I guess that'll be it for this wing for now. Okay, so if you're sticking around, you're probably wondering about the 3D files for this wing. I don't know if anyone's actually going to print this wing out, but I do have it. I have it on Colts 3D right now. It's in the link in the description. But I just try to make a few minor changes so it could actually like be more printable, not just like you need a bunch of different materials, but not too much that I have to reprint the whole plane and just test it out again. It's pretty much the exact same. The things I did change was I did add an air duct to the actual 3D printed hatch. I 3D printed a hatch locking mechanism. I can't do it with one hand right now, but I 3D printed it so it doesn't have to be using an empty screw. I 3D printed those into the body so you can actually hand launch it. And then I rotated the motor mount a little bit just so then the wires can go in. I thickened the vertical stabilizers a tiny bit so they would be a bit more durable. But that's pretty much it. And I did add adapters for the hatch and nose cone for different FPV systems. So this one is the Walk Snail HD Nano V3. I have one with no FPV system, so it's just like with a GPS and flight controller. I have one for the DJI 03. I have one for the Walk Snail HD Kit V2, and then I have one for the DJI 04 Lite. I'm a bit unsure if the DJI 04 Lite like actually works with the hatch and everything fits. But honestly, like if it doesn't fit, you should be able to like make adjustments with like a razor blade and stuff. Like I know it's 3D printed, but it should work out. Work out. It's like again, I didn't spend that much time into making it super easy to print. The whole point of this project wasn't for it to be like a 3D printed design for people to print. So you're gonna need like supports for most of the parts, which you know isn't that great, but it's like what what needs to be done. Yeah, I guess that's pretty much it. Try to unlock this. Yeah, so I mean, I don't really know what else to say, I guess. Oh yeah, I did have the option for because like my motor mount I'm using, it works for the 1408, but also works for the 1404 motors, and those you can use on like a 2S setup, like a 5000 kV motor. It would be interesting to try. I might end up like repairing this and like switching the motor out with a 2S motor and trying it out with like a 2S 18350 battery. I haven't tried that yet, but that is an option I said in the files. So I mean, people could try that out if you want. You can try that out if you want. But I'm not making a video about how to build it because I'm not reprinting all the parts and building it. But I tried to include as many instructions as I could. If they're not that clear, I linked the Discord in the description. So yeah, ask away if you have questions because I did want you guys to be able to build this plane up and fly it. I mean, it's like honestly, I like it. It flies pretty good. So yeah, this current plane I have, it is not sub 250. It is like 270, which is like not that bad. It has like HD FPV, flight controller, and a fairly small battery. So like I think that's pretty good. If you're just building like a standard 3-channel plane with no flight controller or anything else, you could definitely get this thing under 250 grams. But you know, it's 3D printed, so getting it under 250 is going to be a bit trickier if you want like HD FPV. But yeah, that's pretty much it. I'm making sure I'm not missing anything in the Colts 3D files, but I don't think I am. And again, if I am, I can easily just edit the design. But yeah, that'll be it.